Alright, the United States Environmental Protection Agency 542F01005. Part 2 Assist Guide to Permeable Reactive Barriers. What are permeable reactive barriers? Permeable reactive barriers, or PRB, is a wall built below ground, clean polluted groundwater. Wall is permeable, which means its tiny holes allow groundwater to flow through it. Reactive materials in the wall trap harmful chemicals and change the chemicals into harmless ones. Clean groundwater flows out the other side of the wall. So this is the ground surface, the clean soil, the groundwater being treated, the polluted groundwater, your permeable reactive barrier, reactive materials, clean groundwater. How do they work? A permeable reactive barrier is built with digging a long, narrow trench from the path polluted groundwater. The trench is filled with reactive material that the cleanup of the harmful chemicals, iron, limestone, carbon, are common types of reactive materials that can be used. Reactive materials may be fixed in sand to make it easier for water to flow through the wall rather than around it. Sometimes the wall is a part of the funnel that directs the polluted groundwater to be a reactive part of the wall. The filled trench of the funnel is covered with soil and usually cannot be seen above ground. The different materials used for the trench depends on the type of the harmful chemicals of the groundwater. Different materials clean up pollution through different methods. Trapping or sorbing chemicals on their surface, for example, the carbon has for the surface that the chemical sorbs through the groundwater pass through. Precipitation chemicals. They're dissolved in water. That means the chemical settles out of the groundwater into solid materials, which get trapped in the wall. For example, limestone can be dissolved in metals, causes dissolved metals to precipitate. Changing in chemicals and harmless ones. For example, the iron can change sometimes solvent and harmless chemicals. Encouraging tiny bugs or microbes in soil to eat chemicals. For example, the nutrients and the oxygen in the permeable reactive barrier help microbes grow and eat more chemicals. Microbes and complete digested the chemicals. They can change them into water, harmless gases, such as carbon dioxide. How long will it take? Cleaning groundwater with a permeable reactive barrier may take many years. The time it takes depends on the two major factors vary on site to site. Type and amount of the pollution present in the groundwater, how fast the groundwater moves with the permeable reactive barrier. Groundwater may move a few inches and hundreds of feet per year. It spreads varies from site to site. Are permeable reactive barriers safe? Have a good safety record, and once built, have no moving parts, equipment, and noise. Reactive materials encased in the permeable reactive barrier trench are not harmful to the groundwater and to people. Polluted groundwater is cleaned underground, and cleaning up workers can avoid contact with it. Some soils which may be polluted may be removed from digging the trench. EPA makes sure that the polluted soils are handled safely. For example, they cover loose soil to keep the dust and harmful gases out. The EPA tests air makeup to ensure that the dust and gases are not released. If the soil is polluted, it may be cleaned by using another cleanup method, or the soil is disposed of properly in a landfill. The groundwater is tested regularly to make the permeable reactive barrier work. Why use a permeable reactive barrier? Permeable reactive barriers work best at sites with loose, sandy soil, steady flow groundwater. Pollution should be no more deeper than 50 feet. Permeable reactive barrier clean up many times pollution underground. Since there's no need to pump polluted groundwater above ground, permeable reactive barrier can be cheap and faster than other methods. Very little waste needs to be disposed of in the landfill, which also saves money. There are no parts to break, there's no equipment above ground, so property can be used while it's being cleaned up. There are no energy costs to operate a permeable reactive barrier because it works with the natural flow of groundwater. Permeable reactive barriers have been installed at more than 40 sites in the United States and Canada. Our Citizens Guide to Soil Vapor Extraction and Air Spalling. What are soil vapor extraction and air sparging? Soil vapor extraction, or SVE, moves harmful chemicals in forms of vapor from the soil above the water table. The vapors of the gas of the chemical evaporate. The vapors are extracted and removed from the groundwater, applying a vacuum to pull the vapors out. Air sparging uses air to help harmful vapors from the polluted soil and underground and groundwater below the water table. When it is pumped underground, the chemicals evaporate faster, which makes it easier to move. Like soil vapor extraction, a vacuum exerts the vapors. Certain chemicals like solvents and fuel evaporate easily. Soil vapor extraction, air sparging work best on the type of the chemicals. Vapor extraction, air sparging are often used at the same time to clean both soil and groundwater. How do they work? Soil vapor extraction requires drilling extraction wells with a polluted area. These wells are drilled into the soil but not the groundwater. Attach the wells and the equipment with create the vacuum which pulls the air of the vapors from the soil up to the surface. Air injection wells can be drilled to help clean up. Air injection well pumps air into the ground where the air causes the pollution to evaporate faster. Sometimes air vents are used instead of air injector walls. Air vents pump air and provide passage of the fresh air that enter the groundwater. The number of the air injector abstractions as well range from 100, depending on the size of the pollution. Once the extraction well pulls air and vapor out of the ground, special air pollution control equipment collects them. The equipment separates the harmful vapors from the clean air. The vapors absorb stick and solid materials, or they condense to liquids. These polluted soils and liquids are disposed of safely. Air sparging works very like soil vapor extraction. However, the wells with the pump and the air ground are drilled water-soaked soil below the water table. The air pumped into the well distributes the groundwater. This helps the pollution change into vapors. Vapor rises from the drier soil above the groundwater and pulled out of the ground extraction wells. Harmful vapors are removed the same way as soil vapor extraction. Shows your pollution, air injection, air spalling, air in extraction well, air pollution control equipment and water control equipment and water table. The air used in soil vapor extraction, air sparging, helps clean up pollution, encourage growth of the microbes, tiny bugs are found naturally in soil that use the pollution for food. When microbes completely digest the pollution, they can change the water and harmless vapors. Air soil vapor extraction, air sparging safe. And are they safe? When properly designing and operating soil vapor extraction, air sparging, or safe cleanup methods, no one has to dig pollution, no chemicals, just air are aided to ground. EPA makes sure harmful vapors are collected and disposed of properly. How long will it take? Cleaning up the site of the soil vapor extraction air sparging can take years. Time depends on several factors: size and depth of the polluted area, type of the soil, the conditions. Wet or dense soil can slow process. Type of amount of the harmful chemicals present. Air injected in the ground can be heated to speed up the process. The heated soil helps to evaporate the chemical faster. Other sources of the heat, like steam and hot water, can be pumped in the injection well to heat up the soil. Why use soil vapor extraction air sparging? Soil vapor extraction and air sparging are quicker than cleanup methods that rely on natural processes to do the work. In general, the wells and equipment are simple to install to maintain. They can reach greater depth of methods involved in the digging up soil. Soil vapor extraction and air sparging are effective, removing many types of pollution that can evaporate. Both methods can be used with other methods to clean up types of pollution as well. Both methods work in loose soils like sand, gravel, but both work well under many types of conditions. Soil vapor extraction, sparging are often chosen to clean up Superfunded sites. EPA selected soil vapor extraction for use of approximately 196 sites, air sparging using roughly 48 sites. A Citizen's Guide to Thermal Desorption. What is thermal desorption? Thermal desorption is harmful chemicals of the soil, other materials like sludge and sediment, by using heat to change the chemicals into gas. These gases are collected with a special equipment to dust. Harmful chemicals are separated from the gas and disposed of safely. The clean soil is returned to the site. Thermal desorption is not the same as incineration, which is heat that destroys chemicals. How it does work: thermal desorption is usually called the desorber to clean up polluted soil. Soil excavated and placed in desorber. Desorber works like a large oven. When the soil gets hot enough, the harmful chemicals evaporate. To get the soil ready for the desorber works, they need to crush it, dry it, blend it with sand, remove debris. This allows the desorber to clean the soil more evenly and easily. Shows polluted site, desorber, gases for collection equipment, clean air, harmful chemicals disposed, and the desorber, clean soil tested for pollution, clean soil returned to site, polluted, disposed of safely, and cleaning used another method. During each step of the process, works with the use of special equipment. The control depth of the soil to collect harmful gases. The release into the air, polluted gases separated from the clean air using gas collection equipment. The gases are then changed back into liquids and or solid materials. The polluted liquids or solids are disposed of safely Before returning the clean soil to the site, the workers may spray it with water and cool it and control dust. In soil that still contains harmful chemicals, works clean and further placing it back in the desorber, or they may try to clean up the methods instead. If the soil is clean, it is returned to the site. If the soil is not clean, it is sent to the landfill. Is thermal desorption safe? Thermal desorption has been used at many sites over the years. EPA makes sure that the materials are handled safely in each stage of the process. EPA tests the air to make sure the dust and gases not released into the arm harmful amounts. EPA also tests the soil to be sure the clean report before return to site. All equipment must be federal and state local standards. How long will it take? Thermal desorption system usually cleans over 20 tons of polluted soil per hour. The time it takes to clean up site using thermal desorption depends on the amount of polluted soil, condition of the soil, wet or dry as contained lost debris, the type of the amount of the harmful chemicals present. Cleanup will take only a few weeks on a small site with a small amount of the chemicals. If the site is large, chemical level with a high cleanup, it can take years. Why use thermal desorption? Thermal desorption works as a size of dry soil with certain types of pollution such as fuel and oil, coal, tar, chemicals that preserve where it's dissolved. Sometimes thermal desorption works where some other cleanup method cannot, such as sites that have a lot of pollution in the soil. Thermal desorption can work faster cleanup method than most. The important polluted site but it needs to be cleaned up quickly, so it can be used for the other purpose of the equipment. And the thermal desorption often less cost, less ability to operate with equipment for the cleanup methods using heat. EPA has selected the thermal desorption to clean up to 59 Superfunded sites. Or the Citizens Guide to Soil Excavation. What is excavation? Excavation digging is polluted soil so that it can be cleared and disposed of properly within landfill. Soil is excavated with construction equipment like backhoes and bulldozers. How does it work? Before the soil can be excavated, the EPA must figure out how much there is in the EPA to determine the type of the harmful chemicals in the soil. This requires research on past activities of the site as well as testing the soil. Once polluted areas are found, digging can begin. Backhoe, bulldozer, front-end loaders remove the soil and put it in the tarps and the container the soils are covered to prevent wind and rain from blowing the wash away with the covers or keep the works or other than need people near the site without coming in contact with the polluted soil. Digging is complete when the testing of the results remain. Soil does not pose risk to people or the environment. The polluted soil may clean up the on-site with the taken elsewhere for purpose. And the Citizen Guide to Soil Washing and Thermal Desorption. Soil may also have disposed regulated landfill. Soil is clean and may be returned to the holes it came from. This is called backfilling the area, which may also be backfilled with clean soil from another location. After excavation is backfilled, it may be landscaped to prevent erosion, or it may be paved, prepared for some other use. Is excavation safe? Excavation safely removes the most type of the polluted soil from the site. However, a certain type of the harmful chemicals requires special safety precautions. For example, some chemicals evaporate with the chain within the gas to prevent release of the gases air to the site. Workers may come and cover the ground with foam, draw the vapor into the gas wells. Other chemicals like acids, explosives also require special handling, protective clothing to reduce the damage injured the site workers. How long will it take? As excavation pull the polluted soil may take as little as 1 day or long as several months. Cleaning the soil may take much longer. The total time it takes to excavate the cleanup of the soil depends on several factors. Type of the amount of the harmful chemicals present, size, depth of the polluted area, type of the soil, the amount of moisture in the polluted soil, wet soil slows process. Alright, why use excavation? EPA has had lots of experience using excavation to clean up the sites. Excavation is used most often where other underground cleanup technologies will not work when will be too expensive. Excavation of the soil disposal or treatment above ground is often the fastest way to deal with chemicals that pose immediate risk. Polluted soils deeper than 10 feet generally cannot be excavated method. This must cost effective with small amounts of soil. A Citizen's Guide to Fracturing. What is fracturing? Fracturing is a way to crack the rock, the very dense soil, like clay below the ground. Necessary to clean up the method in itself rather than fracturing is used to break up and into the ground. To help on other cleanup methods to work better, the cracks, which are called fractures, create paths that with the harmful chemicals can be removed and destroyed. How does it work? Harmful chemicals can travel deep and below the ground surface as a result of the reaching the chemical to clean them off with difficulty. Fractures help create paths through racks, dense soil where the chemicals are located. The harmful chemicals can be pumped out over the ground through the wells and treated or clean up materials like microbes, toxins be pumped in down into the polluted area to destroy the harmful chemicals. And assistance guide chemical oxidization. There are three ways to fracture soil and rock. Hydraulic fracturing is a liquid, usually water. Water is pumped under the pressure to holes drilled in the ground. Force of the water causes the soil, sometimes the rock, to crack. It also causes the existing fractures to grow longer. Fracture soils are greater depths. Sand is pumped underground with water. Sand helps prop the fractures open, keep them closing under weight of the soil. Pneumatic fracturing uses air to fracture soil. It also can help remove the chemicals that evaporate, chamber the gases quickly when exposed to the air. When air is forced into the soil, the chemicals evaporate with the gases captured for the treated above the ground. Air can be forced into the ground and find depth within the hole. When air is forced near the ground surface around the holes may rise as much as an inch, but will settle back close to the original level. In both pneumatic and hydraulic fracturing, equipment placed under the ground directs the pressure of a particular zone of the soil that need to be fractured. Or show the pneumatic fracturing, air blast, ground surface, sand, clay, equal fractures, chemical evaporates gases through the soil and air treatment system. Your blast enhanced fracturing uses explosives such as dynamite, fracture rock, that explosive placed in holes and detonated. The main purpose is to create more pathways for polluted groundwater to reach wells drilled in it for pump and shrink cleanup. Is fracturing safe? The proper use of the fracturing safe way to clean up methods works better before fracturing is used. EPA studies the site, tests the method to confirm that it can work. EPA does not conduct the fracturing near underground pipelines, above ground structures that can be damaged. Alright, how long will it take? Fracturing rock and soil does not take very long, and it may only take a few days. However, even with the help of fracturing, actual cleanup may take months and years. The time it takes to clean up the site depends on several factors. Size and the depth of the polluted area, type of the amount of the harmful chemicals present, type of the soil, and the rock cleanup methods used. Why use fracturing? Fracturing you use to help with the chemical within rock, dense soil, but it can be cleaned up with the faster. But the other offer ways of reaching pollution deep in the ground where it would be difficult and costly to dig down so far. Fracturing can reduce the number of the wells needed with a certain cleanup method, which can save the time and receive cleanup costs, reduce cleanup costs. Often fracturing is used to help clean the non-aqueous phase liquid. Chemicals that do not dissolve readily into the ground, the non-aqueous phase liquid, are difficult to clean up when they have few fractures in the ground. Fracturing has been used for cleanups at many sites throughout the country. A guide to incineration. What is incineration? Incineration is the process of the burning hazardous material to destroy harmful chemicals. Incineration also reduces the amount of material that must be disposed of at the landfill. Although it destroys the range of chemicals of the PCB, solvents, and pesticides, incineration does not destroy metals. How does it work? Incinerator is a type of furnace that burns materials such as polluted soil with a control of the temperature with high enough to destroy the harmful chemicals. Incinerator can be brought into the site with the cleanup of the material that can be trucked from the site to an incinerator. Materials placed in the incinerator where the heated and increase the amount of the harmful chemicals destroyed work control the amount of the heat and air in the incinerator. As the chemicals heat up, the changes into the gases which pass through the flame to be heated. Material incinerator, soil ash, landfill, burn on site, gases, and then it goes to air pollution control equipment into the stack, the steam and carbon dioxide, and from the air pollution control equipment, metal and acid and ash particles to proper disposal. Further, the gases become hot to break down the smaller components combined with oxygen from less harmful gases and steam. The gas produced for the incinerator path of the air pollution control equipment to remove the remaining metals, acid particles, ash. Waste are harmful, but must be properly disposed of licensed landfill. The other cleaner gases like steam and the carbon dioxide are released outside of the stack through a stack. Your soil ash remaining incinerator after the burning may be disposed of in landfill burned on site. The amount of the material that required for the disposal is much less than the initial amount of the waste that was burned. Incinerator safe. The incinerator is properly designed and operated that can safely destroy harmful chemicals. It can also run with producing odor without producing odors or smoke. EPA tests the incinerator before and during operation to make sure the gases are not released in harmful amounts. How long will it take? The time for the incinerator cleanup site depends on several factors: size of the depth of the polluted area, type of the amounts of the chemical present, Whether or not waste must be trucked into the incinerator. Large incinerators can clean up to several hundred tons of waste each day. Why use incinerators? Incinerators can destroy some types of chemicals that the other methods they can't. Also, quicker than other methods is, and this is important when the site and cleanup they're using preventing harmful people to the environment. One site, on-site incinerators can reduce the amount of material that must be moved to the landfill. Incinerators have been used to clean up to 136 Superfunded sites across this country. Alright, a citizen guide to in-suit flushing. In-suit flushing is a way of cleaning up harmful chemicals polluting soil, groundwater by pumping water and chemicals into the ground. This helps the flush of the harmful chemicals from the ground by moving it toward well with the pumping of the chemical out of the ground. The process works in-suit, which means the polluted soil is cleaned up in the place that does not need to be dug up. How does it work? The goal in in-suit flushing is to improve effectiveness of the pump and treat cleanup method. The pump and treat clump methods pump polluted groundwater up through the wells of the ground surface where it is cleaned up. Where harmful chemicals dissolve in the groundwater, they can easily be pumped out of the ground. Some chemicals like sulfur and heating oil exist in liquids that do not dissolve easily into the ground. They are called non-aqueous phase liquids. Or non-aqueous phase liquids can remain in the soil for many years, slowly dissolve into the groundwater. As a result, they can be stored with groundwater pollution for a long time. In-suit flushing with the chemicals like surfactants and co-solvents can be dissolved with natural non-aqueous phase liquids. Surfactants commonly found in detergent and some food products. Solvents are alcohols, ethanols, methanols. Used for in-suit flushing, surfactant and co-solvent mixed with water. Mixture is pumped down in the well. Some of the well is drilled in the polluted area that will help dissolve the non-aqueous phase liquids. Mixture can also help move the non-aqueous phase liquids toward the well. Sometimes the surfactant mixtures that may stick absorbed to the soil, but they may increase the amount of surfactant required to move the non-aqueous phase liquid. It happens with the co-solvent can be added with a sufficient surfactants mixture to prevent surfactant from absorbing the soil. In situ flushing, best soil with a very permeable, in other words, groundwater can flow through easily. Situ flushing also works in soil underneath the polluted area, not very permeable, like clay. Clay prevents surfactant and co-solvent from moving below the polluted area. The clay layer does not exist. Surfactant foam method can be used. In this method, air may be pumped up underground with the surfactant water. The air forms the foam that prevents surfactant from moving beyond the polluted area. Alright, so in-suit flushing shows the polluted groundwater, the non-aqueous phase liquid well, the surfactant co-solvent and water mixture grounds for the groundwater level, with the well polluted groundwater removed, cleaned up and above ground. Is in-suit flushing scale safe? It can be quite safe, but there is some potential hazard where workers handle the chemicals pumped down into the well must wear protective equipment. Also, surfactants and co-solvent left behind with the cleanup may be harmful, but some scientists may want to leave small amounts of surfactant and co-solvent in the polluted area just to help in bioremediation. How long will it take? Time in the in-suit flushing and cleanup site, depending on the several factors: size, depth of the polluted area, type of the amount of the non-aqueous phase liquid, type of the soil, the conditions present, how the groundwater flows through the soil, how fast, how long, the way, the path. Clean up the site can take months and years of in-suit flushing. Why use in-suit flushing? In-suit flushing is used to help pump and treat groundwater, one of the few methods that can help the non-aqueous phase liquid in place, avoid expensive digging of soil with the disposal of cleanup depending on the number of the wells, the amount of surfactant co-solvent needed. In-suit flushing can be expensive, difficult to use. However, the in-suit flushing has successfully cleaned up many polluted sites and has been used or being used for 16 superfunded sites across the country. A citizen guide to in-suit thermal treatment methods. What are in-suit thermal treatment methods? In-suit thermal treatment methods generally are two ways to move and mobilize harmful chemicals through the soil of the groundwater by heating them. Heated chemical remove the soil of the groundwater toward the underground well where they are collected pipe of the ground surface. The chemicals can be treated above ground. One may be the cleanup method available. How do they work? All thermal methods working for heat polluted soil within groundwater that prevents help with the push of the equipment, push chemicals through the soil towards the collection walls. Heats also can destroy with evaporate certain types of the chemical. When the evaporated chemical changes within gas, the more easily The soil of the collection wall capture the harmful chemical of the gas and pipe of the ground surface with the cleanup. Thermal methods can be particularly useful for the chemical of the non-aqueous phase liquid or non-aqueous phase or NaPLs, which do not dissolve with the move of the easy groundwater. As a result of the source of the groundwater pollution for a long time without proper treatment. In-situ thermal methods include steam injection, forced injection steam underground through the wells drilled in the polluted area. The steam heats the area, mobilizes the evaporate, destroyed by the harmful chemicals. Hot air injection, some of the steam injection exempt the hot air injected through the walls instead of the steam. Hot air heats the soil, causing the harmful chemicals to evaporate. Hot water injection, similar to steam injection, except for the hot water is injected through the well instead of steam. The hot water mobilizes chemical in the aqueous phase liquid. Electrical resistant heating delivers electric current underground. The wells may be to steel. The heat of the current converts the groundwater water in the soil steam, which evaporates harmful chemicals. Radio frequency heating type involves placing an antenna that emits radio waves in the well. The radio waves heating the soil contain, causing the harmful chemicals to evaporate. Alright, thermal conduction supplies heat and soil with the steel wall of the blanket with the covers of the ground strip of the polluted area. But the heat heats up. Harmful chemicals and are destroyed and are evaporated. The blanket is used for the polluted soil. The shallow steel walls are used for the soil is deeper. Her steam injection shows steam in the well with the steam in the groundwater level of the ground surface of the polluted soil and groundwater steam in the steam of the well and the stream in the collection well. In-situ thermal treatment methods save. These in-situ thermal treatment methods are safe, properly operated, where the chance that gases may pollute the air. Cover is placed over the groundwater to prevent escape, and then the EPA tests for the air to make sure the dust and gases have been captured. Scientists also study whether to kill the microbes or help microbes bioremediate the chemicals. How long will it take? Clean soil and ground watering thermal method may take only a few months to several years. These time depends on three major factors that varies from site to site: time and amount of the chemical present, size of the depth of the polluted area, type of the soil, and the condition present. Alright, why use in-situ thermal treatment methods? Thermal methods speed up the cleanup of the many type of the chemical of the ground. Faster cleanups can mean lower cleanup costs. Depending on the number of the wells made, the thermal methods can be expensive. However, there are some of the few methods that can help clean up the non-aqueous phase liquid in place avoids expansion of the digging up in the soil with the disposal of the cleaning up. Therefore, methods can work in the soils. Some soils, such as clays, where other clean methods do not perform well. They also offer a way of reaching pollution deep in the ground where there would be difficulty costly dig. Thermal methods are being used in several dozen sites across the country, including a few superfunded sites. Alright, a citizen's guide to monitor natural actuation. Monitor natural actuation. Natural actuation relies on the natural process of the cleanup of the actuation pollution in soil with the groundwater. Natural actuation curve of the most polluted sites. However, the right of the condition for the most exist in the underground to clean sites properly. If it's not cleaned up quickly enough, completely enough, scientists monitor and test for the condition of the making such for the natural actuation as work. Monitor natural actuation, or MNA. How does it work? When environment is polluted with a chemical, nature can work in four ways to clean it up. Tiny bug with the microbes that live in the ground with the water use some chemical for the food. While they completely digest the chemicals, they change them into water and harmless gases. 2. The chemicals stick and absorb, which held the place, and it does not clean the chemical, but it can keep them from polluting groundwater leaving the site. 3. As pollution moves through the soil, groundwater can mix with the clean water to produce the dilutes of the pollution, groundwater and chemical. 4. Some of the chemicals, oil of the solvent evaporate, which mean with the change of the liquid to mean with the gas in soil. If the gases escape the air and ground surface the sunlight, it may destroy them in the area. Monitor natural actuation works best when the source of the pollution has been removed. For instance, the buried waste may be dug up and disposed properly, removed using available cleanup methods. After the source is removed, the natural process get rid of the small amount of the pollution remaining in the soil with the groundwater, soil, and groundwater are monitored regularly to make sure that they are cleaned up. How is it safe? Monitoring natural actuation can be a safe process usually used properly. No one has to dig up the pollution. Nothing has been added to the land or water to keep it clean. Manual natural actuation is not doing nothing way to clean up sites. Regular monitoring is needed to make sure pollution does not leave the site. This ensures the people, environment are protected during cleanup. Alright, how long will it take? Time of the manual natural actuation cleanup site that depends on several factors. Type of the amounts of chemical present, size of the depth of the polluted, type of the soil with the condition present. These factors vary from site to site. Cleanup usually takes years, decades. Manual natural actuation is used, but all other methods will not work, except for the take almost sometimes manual natural actuation is used the final cleanup steps after another method of cleanup must be of the process pollution. Alright, why use modern natural actuation? Depending on the site of the manual, modern natural actuation may work just as well as almost as fast as other methods. Because manual naturalization takes place with underground digging and construction are not needed. As a result, there is no waste disposal of landfill, less disruptive of the neighborhood, of the environment, allows cleanup of the workers to avoid contact with the pollution. Modern natural actuation requires less equipment and labor than most methods. Therefore, it can be cheaper to monitoring for many years can costly, but it may cost less than other methods. Manual natural actuation is one cleanup method being used the Superfunded site with the groundwater pollution over 60 other sites. Polluted groundwater manual natural actuation is just one of the cleanup methods being used. Manual natural actuation is used for the oil and gas spills from tanks. Alright, a chemical guide to chemical oxidation. What is chemical oxidation? Alright, using chemicals as oxidants to destroy pollutants in soil with the groundwater. Oxidants help change the harmful chemicals into harmless ones, like water, carbon dioxide. Chemical oxidation can destroy many types of chemicals like fuel, solvent, and pesticides. How does it work? Chemical oxidation doesn't involve the digging up the polluted soil or groundwater. Instead, wells are drilled at different depth of the polluted area. The well pumps the oxidant into the groundwater, oxidizes, mixes harmful chemicals, cover them to break down. When the process is complete, only water and other harmless chemicals are left behind. So polluted groundwater, well, oxidants, and recirculated mixture of the groundwater chemicals, ground surface, and the well. Alright, to clean up the site faster, oxidants can be pumped in one well with another well with the approach of the help of the mixture of the oxidant, harmful chemical with groundwater and soil. But after the mixture is pumped, it is pumped back with the recirculated down into the first well, pumping the mixture continue with the more polluted soil with the groundwater are cleaned up. It can be hard pumped the oxygen to the right spot but into the ground, so before drilling starts, the EPA must stay with the condition of the underground by testing soil with the groundwater with the pollution. How will oxygen spread through the soil with the groundwater to reach? Most common oxygen cleanup of the pollution, hydrogen peroxide, potassium permanganate, which is cheaper. The most oxidants are pumped in liquids. Both have the advantage of deepening it depending on the site. Ozone, another strong oxidant, may become the gas as and difficult to use. And sometimes some sites of catalyst are used with the oxidant. Catalyst is a chemical that increases the strength with the speed of the phosphorus. If the hydrogen peroxide is mixed with the iron catalyst, it produces a strong chemical called a free radical. Free radicals can destroy more harmful chemicals than hydrogen peroxide alone. Chemical oxidation can create enough heat to boil water. Heating causing the chemical of the underground to evaporate, change with the gas. The gas rises from the soil with the under the ground surface of the axe cleaned up, captured, and cleaned up. How long will it take? The time it takes to that chemical oxidation cleanup depends on several factors: size, the depth of the polluted area, the type of the soil, the condition present, how groundwater fills through the soil, the general chemical oxidation, off the rapid cleanup times compared with the other methods. Cleanup times can be measured in months rather than years. Alright, is chemical oxidation safe? The chemical oxidation can be quite safe to use. The potential to have the oxidants for the corrosive, which means the way with the certain materials can burn skin with the people who work with the oxidants must wear protective clothing. Some oxidants can be exposed to the wrong conditions. Explosions can be prevented. However, with the proper designed chemical oxidation system, EPA makes sure the system is properly designed, works all tests of soil, the groundwater, and after chemical oxidation to make sure the site is cleaned up. Alright, why use chemical oxidation? Chemical oxidation being used in the 100 sites across the country. It destroys pollution underground with heavy dig up with the pumping of a transport treatment system. This saves the time and the money. Chemical oxidation can clean up the pollution with the other method that can reach. Like pollution deep in the groundwater, chemical oxidation can be used to clean up source of the pollution. Most of all other methods that are used to remove the source are very slow and more expensive. A guide to pump and treat. Pump and treat is a common method of cleaning up groundwater. Pumps are used to bring polluted groundwater to the surface where it cleaned up and treated more easily. Groundwater is water that is collected in underground spaces between the dirt particles, cracks, and rocks. Groundwater flows underground, may empty the rivers, lakes. Many people rely on groundwater as a source of their daily water needs. How does it work? To remove polluted water from the underground extraction system is built. The system usually consists of one or more wells equipped with a pump when the pumps are turned on. It shows polluted water, ground surface, Your extraction well, holding tank, water treatment system, clean water. Alright, they pull groundwater into wells up to the strip of the water with a holding tank, but then on the treatment system where the clean and number of the treatment method, which can be either to destroy the polluting chemicals or remove the proper disposal. Um, the clean water can then be put back into the ground in the public sewer or into a pond. Water pump and treat effect of the destroy for the pollution must be first taken away, but then will not continue to seep in the groundwater. For example, leaking oil drums and tanks must be removed. The surrounding polluted soil that must be cleaned up. If the pump and treat safe, pump and treat is quite safe when designing and operated properly. Since the polluted groundwater is pumped directly in a holding tank, if they are in a treatment system, no one comes in contact with harmful chemicals. But the harmful chemicals are destroyed and removed. The disposed properly. The clean water is tested, makes it sure it's safe before it put the ground and sewer system. EPA the test of the groundwater regularly during pump and treat process to make sure that all these being collected and not spreading further. Alright, how long will it take? Pumping and treatment and clean up the relatively slow process will usually last 5 to 10 years, but last decades and may take a time. Depends on the type of the amount of the harmful chemicals present, the size of the depth of the polluted groundwater, type of the soil, and the rock in the area. Why use pump and treat? Clean polluted water while still underground is very difficult, sometimes not possible. Pump and treatment is the best remedy in such cases. The pump and treat can also be used to help keep polluted groundwater from spreading into the nearby drinking water wells while other kinds of cleanup actions are being taken. EPA has pumped and treated over 500 superfunded sites. Alright, Citizens Guide to Soil Washing. What is soil washing? Soil washing scrub with the remove of the separate portion of the soil with the must polluted. Reducing the amount of soil with the need for the further cleanup. Soil washes alone must not be enough to clean polluted soil. They must often use the method of finish cleanup. How does it work? Cleaning tends to stick with the soil to do some type of the soil more than others. For instance, chemical sorbs more fine-grade soil like silt and clay than large-grain soil like sand, gravel, the silt and clay in turn tend to stick with the sand, gravel, the soil. Washing helps separate the silt and clay with the larger grain. Cleaning soil works best when the soil contains a much bigger portion of the large grain soil with the fine grain one. Soil washing can be clean up the variety of chemicals such as fuels, metals, and pesticides that can absorb soil. Before using soil wash, use the soil of the polluted area with a sift to remove the large objects like rocks, debris. Sifted soil is placed in the machine called the scrubbing unit. Water, and then it goes cover the polluted soil, sifted scrubbing unit, water, detergent, treatment plant, wash water treatment plant, water use, wash detergent, scrubbing units, clean soil, polluted soil for the second cleanup of the method of landfill. And sometimes detergents add the polluted soil with the scrubbing unit, the mixture of the soil with the water pass through the sieves. Mixing blades, water spray, wash of the silt and the clay with large grain soils separates them. Some of the pollution may dissolve the water, flow to the top of the polluted wash water, remove the cleanup of the treatment plant, cleaning and treatment. When they relieve the scrubbing unit with the discharged silt clay, which contains most of the pollution treated. Test for the chemicals, sometimes all of the pollution, remove the wash water, most of the silt and clay. Need further cleanup, silt and clay may be washed. Again, scrubbing you with a cleaning and another method like bioremediation or thermal disruption. And another option is to dispose of the polluted soils in the landfill. Sand and gravel settle. Bottom of the scrubbing unit also test the chemical sand with the gravel to clean. They can be placed back on the site if pollution is still present. They wash again, scrubbing unit necessary and another method used to finish the cleaning. Is soil washing safe? Soil washing usually preferred to the site with avoid the risk of avoiding the truck of the polluted soil from site to clean up facility clearing, digging, and cleaning up the air pollution control equipment that takes care of the dust and the potential air pollution problems. Chemicals in solid release the scrubbing unit of the air. The EPA tests the air for the site to ensure chemicals are not released harmful amounts. EPA also tests the soil to make sure that it's clean before the place bases and back on the site. Properly designed operated soil washing is quite safe. How long will it take? Time to clean up the site with the soil. The washing depends on the several factors. Amount of silt and clay debris in the soil, the type of amount of pollution in the soil. So with the scrubbing unit, with the largest cleanup of the 100 cubic yards of the soil per day cleanup. Usually takes weeks to months depending on the site. While using soil washing at its advantage, soil washing and they reduce the amount of soil needed. Further cleaning of the production lowers the cost of the cleaning with the cost of disposing of the polluted material. Soil wash can remove many of the type of the pollution works with the soil with the very polluted may not be cost effective with the small amounts of the pollution It's also not a cost-effective for the soil with a large amount of silt and clay. Soil washing may be used in 6 Superfunded sites and other sites across the country. Testing. Or an assistant guide to solvent extraction. What is solvent extraction? Solvent extraction over the chemical extract the cleanup method uses solvent extract room harmful chemicals from polluted materials. Chemicals like PCB or polychloride biethanols oil are used to not dissolve the water instead of the attendant with the stick of the soil sediment and sludge, making it hard to clean up the solve of the chemicals to dissolve the suborb chemicals removed from polluted materials. How does it work? Being solvent extraction, solvent must be dug with the polluted air with the retrieve of the solvent and sifted to remove the large objects like rocks and debris of the sifted solvent, then placed in the machine called an extractor, which makes sure where it is mixed with the solvent. The type of the solvent will depend on harmful chemicals present in material being treated. Shows polluted sifted oil sifted extractor going in the separator and clean soil, and then the separator going in solvent in the back of the extractor, and also from the separated polluted material cleaned up by the second method of placing in the landfill. Alright, the clean soil is tested to make sure the harmful chemicals have been removed. If the harmful chemicals remain in the soil, they're placed back in the extractor. They repeat the process of cleaning of the soil with the sediment, be placed back on site. All solvent dissolve the sorbed chemical solvent drained and separated this with the chemical separated with the solvent. Used solvent may be recycled or reused, clean up more soil. Otherwise, the solvent must be destroyed or disposed within a landfill. If any of the solvent remains in the soil following the treatment of the soil, heated to the removal of the heat evaporates the solvent change with the liquid gas. Gas is removed from the clean soil with the gas cooled. The change back to liquid solvent, which can be recycled and reused. Is solvent extraction safe? Properly designed operated solvent extraction is safe cleanup method of soil with sediment and sludge. EPA tests the air while the materials are being dug. They ensure that the chemicals are not released in harmful amounts. The rest of the process is usually conducted in enclosed area, therefore harmful chemicals and solvent evaporate can be captured and cleaned up. Following solvent extraction, EPA tests the soil to be sure that it is cleaned up with the place back on site. Alright, how long will it take? Soil extraction can lead up to 125 tons of the soil to the site per day. Time to take over the clean site depends on several factors. Amount of polluted soil, type of the soil condition present. Is it wet or dry? Dry containing loss of the debris, type of the amount of the harmful chemical present. Cleaning usually takes less than a year depending on the site. Why use solvent extraction? Solvent extraction uses the cleanup method of chemical that is difficult to remove the soil. Cleaning using solvent extraction is generally quicker than the method of treating the soil in place. Be done to site, avoid the trucking polluted soil to the cleanup facility off-site. This saves money in transport, disposes of the soil with addition. Solvent often can be recycled and reused. Solvent extraction is being used for forest and superfunded sites and other sites across the country. Alright, assistance guide to solidification stabilization. What is solidification? Solubilization refers to the group of the cleanup method to prevent and slow release the harmful chemical of the polluted soil or sludge. The method usually does not destroy the chemicals, they just keep them from moving the surrounding environment. Solidification refers to the process that binds the polluted soil with the sludge and cements into the solid block. Stabilization refers to changing the chemicals to become less harmful, less mobile. The two methods are often used together to prevent exposure to harmful chemicals. Alright, how do they work? Solidification involves the mixing with the soil within substance like cement with the cause the soil with a hardened mixture drives in solid block that can be left in place, removed in another location. The solidification process prevents chemicals from spreading into the surrounding environment. Rain or other water cannot pick up the dissolving of the chemicals as is. She says the mixing and complete cleanup materials in polluted soil, an excavator, water tank, cleanup materials, groundwater, and clean soil. Alright, move the ground solidification does not get rid of the harmful chemicals, it simply traps them in place. Stabilization, change the harmful chemicals in something less harmful, less mobile. For example, the soil polluted with the metals can be mixed with limestone, with the lime reacts with the metals to form metal hydroxide. Metal hydroxide does not move through and out soil easily. Solidification stabilization method may or may not require the soil that's being removed. Sometimes it's better to dig in the soil, placing a large mixture above the ground to be sure that all the polluted soil mixed with the cleanup material, cement, and lime. The mixture may then be returned to the ground soil, placed in the landfill. All other sites include, instead of digging up the soil, the mixed place with the cleanup materials. This is then covered by the cleanup soil with a pavement and the solidification stabilization completed. The EPA tests the surrounding soil to make sure there's no pollution is missed. and solidification stabilization saved in order to make sure the safety of the remedy. EPA test the fixture, make sure final mixture conform the proper sealing harmful chemical for strength, durability, solidification, stabilized material. Some EPA will replace restrictions on the areas received solidification, stabilization, land use restriction can prevent further damage to the treated area. Alright, how long will it take? Solidification and stabilization may take weeks, months to complete, depending on several factors from site to site, type of the amount of the chemicals present, size and depth of the polluted area, type of the soil, of the geological condition where mixing occurs, the placing of the mixing tanks. Why use solidification and stabilization? Solidification and stabilization provides a relatively quick, low-cost protective threat of the possible harm chemicals, especially metals. Solidification and stabilization has been chosen as a part remedy of 183 Superfund sites across the country. Our site guide, a citizen's guide to vertification. What is vertification? Vertification is the process of permanently traps harmful chemicals in a solid block of glass-like material that keeps them from leaving the site. Vertification can be done either in place or above ground. How does it work? Vertification uses the electrical power to create the heat needed to melt the soil with the four rods called the electrodes are drilling in a polluted area. Electrical current pass between the electrodes, melting the soil between them. Melting starts near the ground surface and moves down. As the soil melts, the electrode sinks further in the ground, causing the deeper soil of the melt. When the power is turned off, the melted soil causes vertifies, which means it turns into solid block and glass-like material. The electrode becomes part of the block. The vertified original volume of the soil shrinks. Discover the ground surface of the area to sink slightly to the level of the sunken area filled with clean soil. During verification, these electrodes in the metal soil and electrical current and hood above the ground surface, and after vertification, you get the soil glass-like block soil with the ground surface. The heat used in milled soil can be destroyed with the harmful chemicals coupled with the others to evaporate. Evaporated chemicals rise through melted soil with the ground surface here a hood where it's covered with a heated area collects the chemicals. The chemicals are sent to the treatment system, which are cleaned up. The harmful chemicals remain underground, become trapped in the verified block, which in then place prevents the rainfall with the groundwater flow with the wind of the transporting chemicals off-site. Is vertification safe? When properly, vertification can be quite safe. The gas hood must be large enough to cover the polluted area so they capture all the chemicals released in the soil. Any wet soil must be dried first to prevent steam from forming. The release of steam on the splat can splash hot melted soil above the ground. Third, further prevents the site workers from being splashed. Fortified block of the left place from the permanent, not harmful to the people. However, the EPA may limit the construction of land to avoid the damage to it. EPA also tests soil and groundwater near the vertified block to make sure the chemicals are not being released. How long will it take? Time it takes for in-situ vertification cleanup of the site depends on the several factors: size, the depth of the polluted area, time, and the amounts of the chemical present in the hot well of the soil. The well set. Soil must be dry, which takes more time than general in-situ verification. Offers fast cleanup time, but most methods cleanup can take up to a few weeks to months rather than years. Why is used vertification? Vertification has been used at sites of the country, including Superfund sites. Clean up several types of chemicals and soils. By cleaning up soil in place, it avoids expensive digging up soil, trucking it to the landfill for the disposal. Vertification also tends to be faster than other methods. And that is your completion of all your citizen guides by the EPA for spills and your EPA citizen guide to Superfund and cleanup techniques. Testing.